I'm Anil Kumar sharing with you a test question on quadratic functions application. The question here is, the height of a rocket in meters above the ground after t seconds is given by h of t equals to minus 4.9 t square plus v0 t plus h0. Suppose that an object is fired upwards at an initial velocity of 280 meters per second. When does it fall back on the ground level? And part B is, when does it reach the height of 2120 meters? Now for this particular situation, let us write down the equation first. The equation is h of t equals to minus 4.9 t square plus v0 t, where v0 is the initial velocity and h0 is the initial height, right? Which is not mentioned here, but you should know. So v0 is the initial velocity and h0 is initial height. Suppose that an object is fired upwards at an initial velocity of 280 meters. So v0 is given to us as 280 meters per second. And the first statement was the height of the rocket in meters above the ground. After t seconds, it is given by this. But we are not given where it is fired from. So we will assume that it has been fired from the ground itself. And our assumption is that h0 will be 0, right? So that is our assumption for this particular question. Keeping that in view, we can write the formula now as h of t equals to minus 4.9 t square plus 280 t. So that is the formula for us. Now the question is, when does it fall back on the ground level? So when it falls at the ground level, at that time h of t equals to 0, right? So that means height is 0. So we'll equate 0 in this and calculate for t. So 0 equals to minus 4.9 t square plus 280 t. Now to solve it, we can take minus 4.9 t as common factor, minus 4.9 t. We are left with t here minus. We'll now divide 280 by 4.9, right? So 280 divided by 4.9 gives us 400 by 7, which is approximately 57.14. So it is 57.14. Now this expression will be 0 at t equals to 0. So while that is our assumption, h0 is 0 at initial time t equals to 0, right? The other value is t equals to 57.14. So the answer is, when does it fall back on ground? So that is after 57.14 seconds, right? At times you can round it to the whole number 57. So we can say approximately 57 seconds, right? So that is our answer. When does it reach the height of 2120? That means h of t equals to 2120. So we'll equate h of t as 2120 in the original formula, which is minus 4.9 t square plus 280 t. Rearrange, so we get 4.9 t square minus 280 t plus 2120 equals to 0. Now to solve this, we can use quadratic formula, right? So the quadratic formula is t equals to minus b, which is 280, plus or minus square root of 280 square minus 4ac, that means 4 times 4.9 times 2120, right? Square root divided by 2 times a, which is 2 times 4.9, right? So let's use the calculator to find this answer. So within square root we have, so let's do square root 280 squared minus 4 times 4.9 times 2120 equals to, it gives us 28 square root 47 within square root. Let's convert to decimals. 191.95. 191.95. So we get here t equals to 280 plus minus 191.95 divided by, 9.8, right? So that is 9.8. So we have two possible answers. Let's find out what these answers are, right? So that means while going up it reaches, and then while coming down it reaches, right? So let us add 280, divide by 9.8, so we get 48.15 seconds. This is when we add it, so let me write here 48.15, and when we subtract, what do we get? We get 280 minus 191.95 divided by 9.8 gives us in decimals 8.98, right, seconds. So these are two possible answers using the negative and positive values, correct? So at time t equals to 8.98 seconds or 48.15 seconds, the rocket is at the height of 21.20 meters, right? So we can write down our answer. Let's use a different ink. So we can say answer is at t equals to, we can say 9 seconds and 48 seconds, right? It is at the height of 2120 meters. So that is how you can answer this question. I hope that helps. Thank you.